Yeah, my name is Alex. I work at Drive to the Through. This is a social network for people and automobiles, as we like to say. And today I'm going to talk a bit about architecture and in particular the clean architecture on the front end. My goal for the next 1.5 hours is to show you what the clean architecture is and how it can be used in the development on a daily basis on the front end. We'll design an architecture for an online cookie store, which will be using React as a UI library. Also, we'll create and develop one of the user scenarios to feel what it's like to use the clean architecture. And there will be a bit of TypeScript, but only for more convenient entities design. Everything we'll discuss today can be implemented in plain JavaScript as well, although TypeScript is much more powerful in reflecting the entity structure and their relations. So that's why I'm using it. Let's start with a quote. System design, the quote says, is a way to split the system in such a way so that components can be combined together again with ease. I strongly agree, but also I suppose that a good architecture should provide the extensibility for the system because requirements and conditions are always changing and we want the system to be adaptive under those conditions. So we want to change and update the system easily and without any additional obstacles. So the clean architecture can help with this. Clean or onion or layered architecture is a way to split responsibilities and functionality between modules by their relation to the domain knowledge. Domain knowledge in our case is this kind of data and data transformations that reflect the transformations in the real world. We will talk about the domain knowledge in detail a bit later. The clean architecture is sometimes called layered because the whole application is split in 3 layers. In the center, there's the domain. It contains entities, data, and functions that describe the domain knowledge. Domain is an application core. It is what makes the application different from any other apps. We can think of the domain as of code that won't change if we decide to switch from React to Angular, for example, or if we need to add another user scenarios. In the case of online store, the domain would contain entities for users, for products, for orders, user card, and functions for changing their data. In general, these modules don't need to change when we add or change, for example, the authentication. They just describe the real actors and processes in the real world area that our app is applicable to. Around the domain is the second layer, which is application layer. It contains user scenarios, or they called use cases. They describe what happens when an event is triggered. For example, the add a product to a cart is a scenario, which is a use case. It describes what happens after the user clicks a button in the UI and adds a product to the cart. All the fuss after, like talking to the adapters for DB, third-party APIs, or re-rendering the UI, all of this is part of the use case. Also, the application layer contains ports, which are specifications that describe how our app wants to communicate to the external world. Usually, a port is an interface, which is just a behavior contract. We'll examine them in detail a bit later as well. On the third layer, there are adapters to the external services. They make inconsistent third-party APIs consistent to our app. The most important part here is that we don't change our app to be able to talk to external services. Instead, we add the intermediate entity, an adapter. It kind of translates the external service API to our needs. The more distant from the center the functionality is, so like in this direction, the more it is service-like. So the domain is the core for our app. Application describes scenarios, and adapters, they are just help to talk to its external world. And notice that we haven't yet mentioned object-oriented programming. It is a misconception that clean architecture and object-oriented are tightly, tied together. They are kind of orthogonal, and we will show in the example that we can use the clean architecture without even writing in OOP style. The clean architecture declares some rules, and one of those rules is a dependency rule. It says that only external layers can depend on internal ones and never otherwise. So this means that the domain, for example, cannot depend on anything. It can be broken, but we will talk about it later as well. Application layer might depend on the domain, and adapters might depend on anything. Well, because they are adapt some stuff. This rule can be broken, but we should not do it very often. For example, sometimes it's easier to use helper in the domain that can be used somewhere else, just to reduce, for example, duplication of the code. It is, well, it may be usable, but I will show the example of the problem later as well. So also I've published all of the source code that we will create today on GitHub, so we can check it out after the conference. So okay, clean architecture, blah, blah, blah. What's the point? This approach has several advantages. First of all the core functionality is independent and gathered in the single place in the domain. Since it is independent, it's easier to test it. It's easier to update it when requirements change. And in general, well, check if this code fits the expectations. User scenarios are described in different places as well. They dictate how and what external services we might need and how they should behave. We sort of adapt the outer world for our needs and not adapting ourselves to the world. The services become replaceable because, external services can be replaced because of the adapters. As long as the application port is the same, we don't need to change our code because external services have changed. We need to change only the adapters. We create a barrier for necessary updates, and also we create a barrier for runtime errors. The changes in the external code don't affect our app right away. We would only need to change the adapters. Of course, architecture is only a tool, and every tool has not only advantages, but also costs. And the main cost of the clean architecture is time. We will need more time both for design and implementation, just because we'll need to split the system and decide where to do it, how to do it. Also, we can't predict the future, so we will need to design the system in such a way that will allow us to extend it after the requirements change, and they also do. So that's a hard thing to do. On the other hand, not every project needs all the layers, all three layers. In general, the canonical clean architecture implementation is not always a convenient way to develop at all. We might want to compromise some decisions in the design and implementation sometimes. I will show an example of such compromises as well. We can suddenly make the onboarding process more difficult for new developers. Since every tool requires the knowledge of how to use it, we can possibly create a system that requires learning process. Also, we might unintentionally overcomplicate things, and that will make the onboarding process even more difficult. And finally, specifically for front-end, the canonical implementation can increase the bundle size for the browser. We must watch over the final code that we ship to our users and maybe cut some angles in the system when it's not as dangerous as it might get. The less code, the better. So how to manage costs? What to do to prevent really huge and expensive decisions. In my opinion, there are two minimum required actions that help to manage costs. First of all, we need to extract the domain because the domain is what helps to determine how the system even works and what's it supposed to do. When we extract the domain, new developers need to spend less time trying to understand how the app is working and what its goal and what the relationship between different modules are. Even if it didn't add another layers and only extracted the domain, it still would be easier to refactor the app after when the domain is extracted. Other layers we can add later if we need, or maybe not add at all. And the second rule I wouldn't recommend to break is the dependency rule. External services should adapt to our needs and not otherwise. If we change our app to be able to call the search engine, something's gone terribly wrong and we must stop and reconsider the design approach. This will prevent the problem from spreading and corroding the code. Okay, now let's try to design some stuff. Let's create an online cookie store. I've got one of these apps right here. The store sells different cookies. They may have different ingredients. Ingredients are listed in the lists of each cookie. Users can choose cookies and order them. For the payment, we will use external payment system. The main page contains the list of products. We can buy a cookie only if we are authenticated. So the login button reroutes us to authentication form. Let's try to authenticate. And then after successful login, we can add some cookies to the cart. Not every cookie can be bought though. The user has allergies and preferences. If a cookie contains an ingredient that causes an allergy, user won't be able to add it to the cart. Let's add some other cookies. This one and this one and this one. When the cart is full, we can order those cookies. The checkout form is located here. Don't mind the design. I am the developer, I'm not the designer. So it's just a simple HTML with some glittering of CSS and fonts. So checkout form here, let's try to check out. And when we paid for the cookie, we created a new order. A list of orders is located here. This was a working version of the store. Now let's try and recreate it using the clean architecture. Again, the whole source code for the whole store I published on GitHub, so the link will be in the resources at the end. You can inspect it as well. But now let's decide what to start with. I recommend to start with the main design. We have to determine what entities and functionality in general required. And we need to determine what layer to add to them. And the right place to start with is the domain. So what will be in the domain? There should be types of the entities like user type, product type, cart, order, factory functions for creating those entities, or maybe classes if we write in OP, and various functions that describe data transformations on those entities. But those only the functions that rely only on the domain knowledge and nothing else. For example, final price calculation is the domain function because it relies only on the list of products and their properties. Determination if the user has an allergy or an allergy for an ingredient is also the domain function because it reflects the relationships between the entities. In the application layer, we will have payment and checkout, also interaction with products like adding to cart, updating the product info, etc., and also application ports. Those are interfaces that describe our preferences and how to talk to external world. And finally, in the adapters layer, adapters to the external world. UI framework, in our case, it's React. This is a driving adapter because it sends signals to our app. All other adapters, they will be driven because they get signals from our app. First of all, API module that sends signals to our backend. Local storage model, well, for example, Redux, Mobix, whatever, and some other third-party stores, third-party APIs. In our case, it's the payment system, well, which is not really the service, it's just the dummy TS file, but we'll get to that. So the diagram looks like something like this. Notice that the more service like the code, the farther it from the center. So this is the core, this is scenarios, and this is just entities that help us to talk to these different services. We can refer to an MVC analogy here. MVC is the model view controller paradigm, where the model is like the domain entities, for example. Controllers are data transformation in the domain and use cases. And the driven adapters is like the view. Well, conceptually, the ideas are similar. However, the analogy is not quite full, so I cannot refer to it fully, but it can be used to determine the domain. Okay, now let's start to designing the domain. The domain has 4 modules: user, product, cart, and order. The main actor is the user. We will store the data about our users in the storage on the front end. So we want to type this data. Let's create a domain type for the users. Let's go to the code. For convenience, I put the code in the directories that have the name equal to the architectural layers. So domain, application, services. I will make a note about this kind of splitting and the alternatives later. Right now, let's just focus on the domain and type a user entity. So we need to create the type for the user. Let's write export type user name, which is just an alias on string. Export type user, which has ID, which is unique ID. It should have an email, which is a type of email, name, user name, preferences, which is just a list of ingredients, and allergies, which is also a list of ingredients. Okay, our users collect cookies in their carts. So let's add those types as well. So in the product, we need ID, title, price, and toppings, just simple and the most simple form, the simplest form of the cookie and the cart. Let's go to domain product TS and create the type for our product title, which is just a string. Export type product, which has ID, again, unique ID, title, product title, price, which is price cents. I like to, well, first of all, we don't need to store the currency, so we can use just a number instead of an object. Of course, in the real app, it wouldn't be just enough to store the currency in a number, to store the price in a number, but for the sample app, it's much more than enough. And toppings, which is a list of ingredients again. Okay, so products go to the cart. Let's create a type for the cart as well. Export type cart. It has a list of products. And after the payment is created, after the payment is completed, we need to create an order. This order contains the products from the cart and the reference to the user. So let's create this type as well. Go to domain order, and first of all, create order status, because it can be in different statuses. It can be new, it can be in delivery right now, it can be completed, for example. Let's just have the 3-1. And now let's type the order. It will have a reference to the user. It will have user ID. Now, unique ID. It will have products, and it should have date and time when it's created. So let's take time string, status, order status, and total price for all of the products that we have, price cents. Okay, right now, we already can perform a reality check and test if created entities have correct relationships, relationships with each other. Is it okay that the user creates an order? Yes. Is it okay that the cart consists of products? Okay, yes. Is it okay that products from the cart go to an order? Yep, etc. So at this time, we can find multiple design mistakes like cyclic dependencies, unused entities, insufficient data types. And notice, we haven't yet even written a single line of production code, only types, but already we have enough data to test our system just because we designed the relationships between our entities. So the main interaction seems good. And now we can jump to data transformations. So data we just typed is going to be transformed in various ways. For instance, we can add products to the cart. So that's the transformation. So cart state is going to change. For this kind of transformations, we'll need special functions. Example, to check if a user has an allergy, we can create a function in the user module that can be something like this, has allergy. It will take a user and an ingredient, and it should return a Boolean. If user has an allergy, if allergies includes the ingredient, we will return true, otherwise we will return false. And also we can create as preference function. Preference. And here, preferences. So this function is the main function, all of these functions, because they deal only with transformations on the domain data. We don't depend on anything else. So basically, it's just a mapper that maps a list of products with a Boolean. It doesn't depend on anything except for these arguments. And so this allows us to name this function in the main function. This also makes a function pure, and this will be important later on. Pure functions are the functions that don't produce side effects. Okay, we can check if the user has an allergy. What else to do? We need to create a function that can perform the addition to the cart. So, okay, go to the main cart and create a function called add product. It will take a cart and it will take a product that we will need to add. Unfortunate. And it will return the updated cart. So let's just copy the original cart and then update products. So cart products, oops, and then add new product. Okay, and for creating orders, we will need to create another domain function in order TS. Oh, sorry, I forgot something. First of all, we need to, as well as adding products, we need to check if the cart contains products. So contains cart and product check product again, and then Boolean return cart products if some of the products have an ID that is equal to product ID, we will return true, otherwise we will return false. So when we added some products to the cart, we need to create an order to process the payment. So we're going to order.ts and we create a function called create order. It takes the user, it takes products. Well, we could also take cart and get products from it, like from there, but for more straightforward code, I would like just to use products right away. Product list and return new order. So if we need to return an order, we first of all need to return a user ID. Then we need to pass products, all of them, and create a created field. So when it's created right now. So let's just new date to I saw string. We need to pass the status. It's new because it just created right now, and total. So total price we'll calculate a bit later. Here, we might want to extract the current date into a function and use this function, just like, for example, like this export function, current date time, which can return date time string, and return this stuff. This function we can use here. And this line is an example of the domain dependency. So in the canonical implementation, this should be avoided because we're not allowed to depend on anything in the domain. However, I feel that this situation is not as dangerous as it might get. I think that we can depend on functions that themselves rely only on the language features. Well, right here, we don't use any external libraries. We don't use any additional modules. It's just a function that reduces the code duplication. So here we can violate the dependency rule. However, if we would use some library here, for example, I don't know, data finesse and something like now to I saw string, for example, this shouldn't be done just because additional dependency, it makes the whole domain depend on this library. And if library changes, we need to update the domain. And this is against the whole philosophy of clean architecture because we need to keep the domain as independent as it can get. In the case of just language features, it is the same as to write this date here. So basically, we just remove the duplication and use the helper function. It can be violated, but I wouldn't recommend to use some external libraries, external services in the domain dependencies. Okay. Next thing we need is the final price calculation because here on us, because here we have a total of 0 currency and it's not good. We need to pass the real price here. So the total price function it will take a list of products and calculate their total sum. I think that this is a product.cs is a good place to create this function. Okay, total price. I take list of products, product list, and it should return price cents. We will take this product list, products, and reduce it to a number. Which number? I will take total result. We will destructure every product to its price. and then we sum total and price of current products. So, okay, now we can use this function right here, total price of products. Again, this also doubtful because it's called cross-component code usage. In the canonical implementation, it's not recommended to just go to neighbor module and use its functions in such a way. But I think that in small applications and in applications that cannot, well, should not be shipped so differently in layers or on features, it can be used as well. So these two lines are kind of dirty. They are not canonical, but I guess it's not very bad to use them in such a way. Again, notice that we design functions APIs in the way that is convenient for us. We take arguments in the way that we want, and we return the result in the way that we want. There are no constraints on the design yet, so we can perform the data transformations in the same way as the data transforms in the real life. So we create an order, we return an order. We use only the arguments we really need to use. And this is another advantage of designing the domain as the first thing in your app. Okay. You might have noticed that I used type aliases that I didn't declare. So like I used type email, I used type unique ID, the type string, price cents. I use these annotations that are located in shared kernel.dts. And there are two things that I want to tell about. I use type annotations to describe types that can occur in the system but aren't exactly connected to the domain. So like email, it can be a domain type, or it can be also just a data type for form validation, or date time string. It's kind of domain, but it's kind of not. So we are not sure if it should be its own domain entity. First of all, I use type aliases to avoid primitive obsession. When a type is more closely related to the real life, it's less chance to make a mistake when writing the code. And even if a mistake is made, it's easier to debug the code with self-describing types rather than strings or numbers. So that's why I use type aliases. Second of all, type that might be related to the domain and might not, like this one or this one, I prefer to specify as the shared kernel. Shared kernel is the data and the code that can be depended on, but this dependency won't increase coupling between modules. For example, we always depend on TypeScript lib.dts for DOM API annotations, but we don't consider those types as a dependency, really. So I use shared kernel in the same way. It's not totally correct, but I suppose this is the most convenient way to consider it, especially in TypeScript, because we can declare annotations that can be used globally, and they really don't increase the coupling between different modules. Again, it's not mandatory to use shared kernel or even type aliases for that matter, but I think they make the code safer for reading, and they really try to reflect what's going on in the real world. Okay, let's go to the application layer because the main is done. Let's try to create the use case. Use cases are scenarios in the application layer, and they describe what should happen after a user makes an action in the program. These scenarios imply the usage of external services and hence side effects. For example, a user authenticates, and for this to work, we need to send the request to a server. We need to get a response, we need to update the UI, change the page, or whatever. We all know that side effects make programs more complicated and harder to debug. Also, our domain functions are already written as pure functions. And how to combine these things together? We would like to keep the purity of the domain and keep the chaos of side effects of external world, like outside of our app. What to do? Application layer can help with this task because it can be an impure context for data transformations. Sometimes this approach is called the functional core inside of imperative shell. And by this, we mean that a command handler in the application layer, it first takes some data from the impure source, like database or data storage. Then it performs pure data transformations, usually by calling the domain function. And finally, it saves the result as, again, side effect. So this makes kind of a sandwich: side effect, pure function, side effect. The main logic is still located in the pure data transformation, and side effects are not mixed together with it. So the code is testable, extendable, and debuggable. And if we correctly pass all the required services, it is whole functional, whole impure context is testable as well. This is the design that Mark Zeman wrote about in his blog. It's called Impurem Sandwich. Totally recommend the this blog post to read. Links will be in the end as well. So, use case. Let's focus on the checkout use case. This is the most demonstrative among others because it is asynchronous, it triggers many external services. Let's just determine what this use case should contain. First of all, we need to create an order, of course. Then we need to try to pay with an external payment system. If the payment wasn't successful, we need to notify the user. If everything went well, we need to save the order and then update local data storage and re-render the page. Okay, so the use case signature should look something like this. We will take user, their card, and then do something. Ideally, of course, the use case should take a command as an argument instead of two separate arguments. But again, let's try to keep it simple and just take two separate arguments. Okay, order creation is a domain function. All the other functionality requires external services. We need to remember that the world should adapt to our needs. And that's why in the application layer, we need to create ports. Ports are interfaces for those external services. These interfaces are convenient for our app. And if an external service has incompatible API, we will create an adapter. Okay, so let's start with creating those interfaces. Which interfaces we're gonna need? We would need notification services, something is went wrong, we need payment system, we need storage. Okay, let's go to application ports. And here, let's create our first interface. Let's start with, for example, payment. The payment service will look like this: expert interface payment service. And it will have only one method, try pay. It's a very naive service. It takes some amount and that's something. Promise of a Boolean. So it takes some amount of money and it returns the confirmation. If everything went well, it would be true. If there are some errors, it would be false. We won't handle errors because it's a huge topic on its own. Sure, usually the payment is performed on the server, but this is a sample app. So we pretend like we perform the payment with the external system right here on front end. And of course, we can replace the payment process with talking to our API server and place the payment there. And by the way, the use case will slightly change and all the other code will be the same. That's the huge advantage of decoupling modules and splitting the functionality in layers. Okay, another important thing that we split functionality in cohesive interfaces by their features. So we kind of follow in ISP, interface segregation principle, to be able to include an adapter that will implement this interface in multiple packages. Again, we'll talk about multiple packages a bit later, but right now we pay attention that payment service contains only features that, related to the payment. Notification service will contain only features that are connected to notifications, etc. Speaking of notification service, if something went wrong in the payment, we need to tell about it. So we can notify the user in different ways. It may be an alert, like window browser alert. It may be an email or even a push notification. So notification service is better to be an abstract as well. So create expert interface, notification service, and it will have method notify that takes a message and does something. Again, we don't need to specify the details of the behavior here. We need to specify the rules of the behavior. So it's a contract, it's a guarantee that the service that implements this interface has notify method that takes a message and does something. We don't really need to know right now what it does. We just need to know that it indeed does. So, okay, we will keep the order in the local store. So the store can be implemented in multiple ways as well. Redux, Mobix, whatever JS. Also, the stores can be multiple for different features or a single big store for everything. Again, doesn't matter. In our case, we will keep different interfaces for different store features, just because it is easier to use different interfaces that are implemented by a single huge store than try to split the single huge interfaces in different nano stores. Okay, so let's create export interface order storage service. It will have a field to access the current order, and it will have a method update orders that will take a list of new orders and will update it in the store. So let's check the use case. We create an order, try to perform the payment with the payment system, notify about all the problems that we have, save the result. Seems okay, seems legit. So now we can write the code for the use case. Let's go to application order products TS. And here, first of all, we need to create an async function. Async function order products. That will take a user and a card. And then it will do something. Since our application layer tries to communicate with an external world via services, we need to describe it. I like to create dummy services that don't really do anything, but they were obliged to implement the service that is typed with. So here we have payment, fire, application service, and const order storage, which is order storage service, and it's also an empty object. These are empty objects right now because we only need to address them. So we need this constant just to be able to call the method that we need. Basically, right now, this won't do anything. Of course, it won't compile because the payment doesn't really implement the payment service. But we even don't need it to compile. We need to address this method, and we need to model all the use case that we're trying to create. And then after, we will create real services that will implement these interfaces, and all things would just be cool. So, okay, let's try and recreate all of these steps that we have here. Create order, try pay, identify, save the result. Okay. Const order is equal to create order, and it will take user and card products. Then we try to perform the payment. Const paid is equal to await payment, try pay. The price will be order total. If something went wrong, if not paid, we return notifier, notify something went wrong, and the function stops. If everything went well, we take the current orders from the order storage. We update storage, update orders with the new order. And then we just of course, order. Okay, so this is the skeleton for our use case. Right now, we don't have these services. And now it's time to go to adapters layer and implement them. So the first adapter, which is inconveniently is not listed here, is the UI port. The port that we will need to create is, well, it provides access to the user for calling a command. So in the UI, it's a button that, when clicked, calls the use case. So let's try and find this button. It's UI by TSX, and it has a to-do here. So basically, it's a form that has a button, and when the form is submitted, it calls the handle submit function, and here we need to call our use case. So let's try and do this. We need to call wait order products and pass here the user and the card. Okay, since we work with React, and nowadays it's trendy to write hooks, let's write hooks. We will expose the use case from other products via hooks. In general, we could pass this function right away without any hooks at all. But since the use case requires, well, it relies on order storage, and this storage will be provided and can be provided only via hooks, I will I will tell why is that a bit later. We will use hooks here as well. So let's try and create a function called use order products that will return this function, which will return order products. Why to do that? we need to access our services. And those services will be exposed via hooks as well, just to show that this is, well, this can be done in React. So the services really can be provided via hooks in another hook. And this is the only way they can be provided. So we need to create those services here, notifier, use notifier, and remove it from here. So let's try and drag all of those services and recreate them here. Use orders, and we can remove them from here. Okay. I like to call this approach a crooked DI, dependency injection, because we don't actually invert dependencies, we just inject them manually. So we go to application, we ask it to give us notifier service, we ask to give payment service, order storage service, and then we pass them in the use case. Ideally, this should be done automatically with some DI container, of course. But in a case with a simple app, it's not required really. Also, the composition of front-end apps is often looks like more like functional composition rather than object composition. So DI container is not a requirement. And in some cases, it might be even more difficult. It might be even more verbose. So let's just use hooks to inject services. Also, the use case may seem hard to test here because we have this hook around it and the services here. So I promise that the use case will be easier to test. So what's the problem? What's the point? We can really extract this function again here, and use the last argument to pass the dependencies. So we can create, for example, some function called and it will be a function. We'll take this arguments, pass them here, and pass them here, and pass the dependencies as well. So we can take those services and pass them here. And then here we can destructure the object and take them from the other. So what's the point of doing this? Since the use case is a function that's independent, we can test it without any React in the test environment. So we can test this function just as a function. We don't need to test this hook in general. And function can be, of course, just tested from here. But again, we don't need this refactoring right now because we don't test our code, and this is not very good. But sorry, got distracted a bit. Okay, yeah. This will make the use case independent from React, well, extraction and refactoring, and more convenient to test. But since this is the only simple app and, well, it's not very tested, so we can keep the previous version and inject services via the hooks. So let's write the services themselves because we try to use them, but they're not there yet. So let's start with the notification service. Services are located in the services folder. It can also be called adapters, but I have the fake API here as well. I have fake data for for the store. So I just wanted to call it services instead of adapters, but it doesn't really matter. So let's start with notification adapter. We go to services notification adapter, and we try to create a function called use notifier, which will return the notification service. I type the result just to make sure that I return, well, right thing. Because if I return here something that is not notification service, TypeScript will tell me that, oops. Yeah, TypeScript will tell me that this method is not presented in notification service, and I just made a mistake. And I need to make this return value implement the notification service. So let's try and do it. We will create notify method, which will take a message and return just a window alert with the message. Since our notification service is the only place that connects our app to this service, we can do whatever we want in this service. So we can call window alert, we can call some device APIs for, I don't know, for push notifications or something else. So basically we can just do anything we want here. And this is the advantage of decoupling modules, because notification service guarantees only the signature of this method. We can do anything we want inside of it. Okay, we created notification. Let's go to the payment. For the payment, we will use the fake API here, which is just a timer that imitates the delay for server response. Let's go to services payment adapter and create a function that's called use payment, which will return payment service. And it will return an object with a try pay method, amount cents, and it will just return fake API with the true value. Fake API will take something that we pass it as an argument and return it after 450 milliseconds. So basically, we will, from this method, return true after half a second. Okay, for the store, we can use storage adapter. And here, let's create a function use orders storage. And return order storage service. And use store. What is this? This is the hook that provides the access to store context. Again, we can use anything we want really, but I use React context just because I'm lazy. And I think that for small apps, it is more than enough. So here in the context, we can create another variable, which will store orders, set orders, and use state with an empty list. And here we can provide orders and update orders as set orders. What's the point of doing this? We use different hooks. First of all, for compiling the ISP. And second of all, we can optimize some processes inside. We can use selectors, for example, or memoize something, or we cache something, whatever. The important part is that it also connects to the app via interfaces, and we're not bound to a specific concrete implementation. So if we decide to switch this storage, for example, to nanostores or effector or anything else, we can use it without rewriting the whole store. We would need just to remove some stuff from here and write an additional implementation. Okay, final diagram. Let's inspect what we've done. The user interacts with the UI, and the UI talks to the application layer. This layer specifies how the UI can talk to it and what to do when a command is received. All the data transformations are encapsulated in the domain, and the external services are connected via ports, which are interfaces. If we decide to change a service, the only thing we will need to change is the service adapter. Well, for example, the payment system started taking really high fees, and we want to switch from one payment system to another. We can replace the adapter and replace the external service. Okay, let's now check if the app works correctly. First of all, of course, it doesn't because we didn't really use those adapters. Add all missing imports, save. Let's, okay, this is just a little quirk. Let me make a little hack here. And then let's try and check the use case. Okay, go to login, try login. Okay, we have some cookies. Let's order them and try to check out. Check out. Okay, order storage is not a function. Let's see what we done. Update order sub. Let's try again. Again, another cookie and check out. And right now, order is created, but the cart is not empty. Okay, let's try and inspect what else to do. Of course, we go to the order products, and here we can see that we don't really empty the cart. So what can we do? We can use cart storage, use cart storage, and then here empty. Right now, let's try and check if the use case is working as expected right now. Check out, the order is created, the cart is empty, and now it's all working. So the reason why I made this mistake with the last unempty cart is to show the feeling of how much simpler it is to find the root cause of the error and fix the mistake, because we know exactly when to look, and it takes less time to fix the bug and find the bug as well. And also the easiness of adding new services and using them, because here we just creating a reference to a new service, and here we just using it. Okay, so in the beginning, I said that the clean architecture can be used without OP, and well, we just showed that this is this can be done. But I want to say that OOP, well, it has some terms and has some features that can help with designing stuff. I mean, they can help with creating the relationships between modules, although it, of course, it has some quirks with hierarchies, and they are not very good. But if we keep the hierarchy of modules simple, OOP can be interesting as well. I recently wrote a post about clean architecture and OOP on frontend, and there I create a 3 images generator with LSystems, Canvas, and TypeScript. And also I use all of the OOP principles and clean architecture principles. The link will be at the end as well. The post, I think, is interesting, so try to look at it. And I said at the start that splitting the code in directories that resemble the layers structure is not very good. The more convenient and the more proficient way to use the clean architecture is called feature slice. Feature slice is kind of hexagonal pie slice, which can take some features from the domain, the application, and the services that can really describe a real feature. And this pie can be a package or a module that can be shipped to our users independently, and it can be used independently, etc. So basically, feature slice is an idea of splitting the application by features. And this is also an interesting approach, so I recommend to check it out as well. And everything I've shown today is not the silver bullet, of course. It's merely a compilation of experience in different programming languages, paradigms, projects. But I think that this is a convenient and robust scheme to build user interfaces. It allows not only to write the extensible and replaceable code, but also to publish different packages depending on the required feature. And I really recommend reading all of this stuff, especially this article, because in this article there are, well, all that I said is just 10–15% of the real hardcore stuff from this example. Really recommend reading all of the sources that I have here. And that is all for I have today. Thanks. I'm ready to answer the questions if there are some.
Yeah, folks, I have some questions, but jump in if you have them.
Huh? Which slide?
Okay, let me then start. So the first one is, I wanted maybe you to elaborate a bit on the approaches, or what would you consider? So we spoke about extracting date and date to a separate kind of helper function. And you said that the principle is if it's like a core language feature, I think it was in the order. But we often, so not all of the core stuff are good, and we often use like third-party libraries like Day.js or Data.fns. And the question is like, okay, we cannot bring it here to the domain. So what, when it should happen then, if not here? So that's, I think, my question.
That's a brilliant question, because it, I forgot to tell the most important stuff about the domain dependencies. Well, if we cannot create a date here, we should take this stuff and we should really pass the date from here. So date time string. So let's call it created. We should remove this stuff and just pass it from the outer space. And the outer space is the application layer. And here, when we create the order, we can pass the created, which can const created, which can be, well, created from here. So we can use external service, for example, when we date time service, and we can use its methods now ISO string, for example. So basically here we use the Imperium sandwich, because first of all, we take the side effect and we call the external service that can work with the dates. Then we use all the clean and pure data and pass it to the create order, and create order becomes really finally pure, so it doesn't produce any side effects. It takes all the data, it creates an entity, and it's done. So after it's done, we can go to order products again. We use this entity and we talk to external services as well. So again, producing side effects. So here it's impure, here it's pure, and here again it's impure. And the data transformation is here, and it doesn't depend on anything. And all of the fuzz about talking to different services is around this transformation. So in the OP case, it would be something like this: const order equals new order and blah, blah, blah. User products and created. Since the clean architecture, it takes its start from OOP, it would be, more canonical to use just class order or something like that uses new. So creating order should be just creating an entity. So it shouldn't just make something like, it shouldn't do much calculations. No.
Yeah, thank you. Folks, any more? Because I have more. Yeah, Alexis, go.
Yeah, I have a couple ones on top of the one that Nick mentioned. You were defining the interface on the application layer, but I don't know if it was just for convenience or is because is that actually the place where our interfaces for the services should be?
Yeah, they should be in the application layer just because application cannot depend on the external services. So if the interface is located on the adapters layer or even further, it would violate the dependency rule. And since the ports are located in the application, we don't really think of those interfaces as the part of adapters. We need to think about them as the parts of application. So it seems like a window from the from the house. We think about those ports as a specification that we want the outer world to talk to us. And yeah, they should be in the application just to not violate the dependency rule and to remind us that those ports should be convenient for us in the first place.
Got it. And the other thing is that you mentioned that the client code can blow up a lot, but I see, of course, this is a very small example, but in the end, it's not the same in the same code. Probably the definition of the interface, which are very useful, but other than that, what are the other risks that you see that just for the architecture you have to write this?
Yeah, that's a good question as well, because in the small applications, well, it doesn't really matter will we do the clean architecture or some other, but in the huge applications, it can be, let me just think of an example. Some use cases might be, we might want to make them independent as well, because we don't want to different use cases to be dependent on each other. And they might create some calculations, estimations inside of them, and it would make the code bigger. Also, the splitting between different entities, if we go too much in the details, we can create so much entities that, well, just create too much classes, too much objects, too much, code, too much entities. And this is the real struggle with designing stuff, because when we try to predict the future, we try to split entities in the atomic, modular, small entities. And if we overdo it, we can create too many of them. And when there are too many small entities, they can, well, produce a lot of code to transform them.
Cool, thanks.
Yeah, I have another one. And it's like, I don't know, an interesting topic as well. So the state managers, and we're all used to it. And but what is a place of state managers in that architecture? Is there a place for them? And maybe not, because yeah. So I've seen the approach that domain is kind of often kept in state managers and kind of used for it. But like, what is your opinion?
Well, I've heard a lot of stuff about state managers and their place in architecture. I know a person who uses effector in the domain, and I am not sure if I if I agree. I think that the place for the state manager is somewhere between the application and adapters. I wouldn't say that the state manager is a third-party service, because we use it to describe the user cases. But it's not the application layer per se as well, because it uses a library. So there is a thing called, let me just find it. There is a thing called application services. And if we zoom to here, so we can see the application layer is split in application services and, well, use cases. I think that application services is kind of the place for the state manager. I'm not sure, because, well, all the stuff that I read about clean architecture is not from front end, and they don't have this problem of state management. But I think that it should be somewhere like here. Maybe it should be hit by adapters as well, but it's not the third-party service, well, in the common sense. So I guess it's kind of application service.
Yeah, and maybe to continue this discussion, as you mentioned, it's like a lot about like clean architecture is usually about like backend, and how do you think it's at all like worth doing on the front end? Because like, okay, in modern apps, we try to push all the business logic, like the hardcore stuff, to the backend, and front end being like kind of very dummy. And so is it worth doing this effort?
Oh, it depends on the application, each application, because when the app is really small, it might not even need an architecture, well, at all. We can just write all the code in a single file and it will work. But in the case of, for example, some applications that don't have backend, as for example, this application, it's the mobile app for managing expenses, and it doesn't have any backend at all. But still it has some logic. And to be able to extend it in the future, I had to come up with some kind of architecture. And I found that this semi-clean architecture is ideal for it, because it really splits the functionality by its relation to the domain. All the domain logic is simple and pure, and it can be moved to another framework, another app, another, well, I don't know, environment. And I guess it's worth it in the cases when the front end is not dummy, and when there is a lot of logic, and when it is hard to manage the logic. Because, for example, if the app is really small and really simple, I wouldn't do it. But I would extract the domain. Let me find the slide. I would extract the domain and I would follow the dependency rule, because it doesn't really make a difference if the app is small or if this is a big app. If the domain is smushed with all of the code base, it's really hard to grasp on what the application is doing. And even in my personal site that is built with Next, I also extract the domain just because it's easier to find all of the types that I use, all of the entities that I use, but it's just a blog.
And okay, I think, well, from my side, feature slices. So what is your experience with it? And so, as I understand, maybe I'm just getting it wrong. So we're trying to kind of encapsulate everything, and so make it shippable like alone without any dependencies. So that means some of the domain logic will interact. So what is the common approach there? Is there like a shared core, shared kernel, like shipped and separately, and then all of those features on top? Or how is it?
You correctly mentioned that there should be some shared stuff. In feature sliced, which is called feature sliced, they called this code just shared code. On projects that I worked with on the backend, we placed some entities in shared kernel as well. So basically, we can place user entity, we can place some product entities in shared kernel. Of course, it has some downsides because shared kernel can blow up and it just wouldn't be easy to work with. But to ship some features separately, we need to have some kind of connection between interdependent modules. Basically it's called shared. Of course, there is more hard and difficult approaches to do it. It's called intercomponent adapters, but it doesn't really, it isn't worth it on front end because it's difficult, it's unnecessary, and we can just use shared code.
Okay, thank you. Yeah, that's it, I think, from my side. Okay, so there is an awkward silence because there are no more questions. And yeah, then we're done. That was an amazing talk. Thank you. And if you have questions, there was somewhere a Twitter handler. If you go to the last slide. So yeah, feel free to reach and ask.
There is an underscore.
Where we can